Lemon!
What happened, Nobita?
Help me, I have a problem.
What's your problem, Nobita?
I don't understand about abrasion resistance of concrete by rotating cutter method and sharpening method. Can you show me?
Yes, I heard about these two methods. But first, I'm going to show you about the rotating cutter method because in our university. So, let's go.
Doraemon,
What is Nobita?
what is abrasion resistance test?
No problem, Nobita. Because we have Celine. So, Celine, what is abrasion test?
Hi, my name is Celine, the artificial intelligence. Your request is rotating cutting method. Let's start. First, I will explain what is ASTM. ASTM is International Standard and Testing Organization, originally called the American Society for Testing Materials. Next is, what is the abrasion resistance test by rotating cutting method? Standard test method for abrasion resistance of concrete or mortar surfaces by the rotating cutting method has the ASTM number C944/C944M. So, we can easily describe the ASTM C944 as ASTM test method for abrasion resistance of concrete by drilled cores and sawed beams of concrete. Gives an indication of relative abrasion resistance of mortar and concrete based on testing of cored or fabricated specimens. This test apparatus consists of rotating cutter and drill press. The main difficulty is maintaining a constant load on the abrasive cutter when using the lever, gear, and spring system of a drill press, which has been eliminated by placing a constant load of 98 newtons directly upon the spindle that turns the cutter.
Oh, I got it.
Oh, look, Nobita, our lab is over there.
Wow.
Welcome, Nobita. Global KMUTT-ITCE56. Are you ready, bro?
Sure, let's do it.
Yeah. First, you need to determine the mass of the specimen to the nearest 0.1 gram. Next, fasten the specimen securely in the abrasion device so that the surface to be tested is normal to the shaft. Then, mount the rotating cutter device in the abrasion device. Adjust the level of the specimen by pull up the specimen to the shaft, approximately 1 cm from the shaft to specimen. After we adjust the level of the specimen, then we rotate the wheel, as you can see, to contact with the surface of the specimen, as you can see in the video. Start the motor and lower the cutter slowly until it just contact with the surface. Continue abrasion with the normal or double load on the specimen for 2 minutes. After contact between the cutter and the surface, At the end of each 2 minutes abrasion period, remove the test specimen from the device and clean the surface to remove the debris using a soft brush or blow the surface with the air. Determine the specimen mass to the nearest 0.1 gram. The minimum test schedule shall involve 3 2-minute periods. For concrete that is highly resistant to abrasion, addition testing may be required, doubling the applied load or the time, or both of them, as shown in the following chart, should be provide more comprehensive information on such concrete.
How about this, Nobita? Did you enjoy our test? Yeah, I really want to know about Sharing method now.
So let's ask Celine then. Celine, what about the Sharing method?
Is the method of BCA. The principle of this method is that the wear resistance BCA of screed surface is assessed by measuring the mean depth of wear caused by a machine with 3 hardened steel wheels rotating over a ring-shaped area for a fixed number of revolutions under a standard load. The mean depth of the wear within the ring pattern is used to indicate the wear resistance of the screed surface at the test location.
Now, Nobita, I will take you to the place that we are going to test about the Sharing method. So now, let's go!
Yay!
Anywhere door!
Where's Doraemon?
This is CPAC!
Wow, it's so exciting. Doraemon, how do we get the knowledge from here?
Okay, I will bring you to Mr. Nakorn Saktong, who know how to test in this Sharing method.
Yeah.
So let's go thank him.
Go.
สวัสดีครับ
Part 2. Setting up. The marking of a template shall be placed in the position on the screed surface and mark the location of the gate. Feed through the 24 holes using a marker pen. The location of the 2 retaining pins shall be marked through the holes on the bar of the template. The template shall be removed. The test reference number shall be written on the specimen at the center of the test area, and the number of the gate position 1 to 8 shall be marked on the specimen. The marks and numbers shall be capable of being clearly seen before and after the test is carried out. The depth gauge shall be placed accurately at each of the 8 measuring positions on the specimen, and the initial reading shall be recorded to the nearest 10 micrometer. The 2 nominal 10 mm diameter retaining pin hole shall be drilled at the marked position. The debris and the dust shall be removed with the brush or by vacuum. The test machine shall be assembled at the test location, and the retaining pin shall be inserted through the feed into the hole in the test specimen. It shall be checked that the abrasion head is free to rotate or not. Press the start button for the machine to begin working. Next is the test operation. The test shall be run for the 2850 plus or minus 10 revolution of the abrasion head using the suitable revolution counter. After we finish the test, then turn off the machine. the restaining pin shall be removed and the test machine shall be moved away from the test position. Any dust or debris created by the test shall be removed by brushing or vacuuming. Depth gauge shall be placed accurately at the edge of the egg measuring position on the specimen, and the reading shall be recorded to the nearest 10 micrometer.
What about the result?
Yes, Monica. Just a minute. I will calculate for you.
For C944 per carat 944M standard test method for abrasion resistance of concrete surface. As seen from the video, we tested the two specimens under both single load and double load methods, which consisted of scrubbing the specimens for 2-minute periods, 3 times. In order to compare which specimen has more surface resistance, we used the values for weight and corresponding number of times to plot a graph. For the first specimen, we can calculate weight loss from the graph, showing the weights and times for both single and double load. We can do this by finding the difference between initial and final weight for each tested method. So, we calculated the weight loss for single load equals 3,821.6 minus 3,819.1 equals 2.5 gram. Weight loss for double load equals 3,807.6 minus 3,804.3 equals 3.3 grams. For the second specimen, we use the same calculation method as the first, but just with a different set of graphed values. The resulting weight loss for single load equals 3,828.2 minus 3,826.4 equals 1.8 grams. Weight loss for double load equals 3,829.1 minus 3,826 equals 3.1 grams. This means that the surface resistance of specimen 1 is lower than specimen 2, and so we can conclude that specimen 2 has a higher surface resistance, about the BS1381. For this test we can classify the type of floor using the average depth from the results in the table. As for the table, we can find the average wear depth from the wear depths for each of the 8 points. For each point we can use the calculation. Wear depth equals final depth minus initial depth. After that we can find the average wear depth by dividing the summation of wear depth by the number of points. As can be seen from the table, our average wear depth equals 0.209 mm from the table. From the BS1381 we have classified the floor into 4 types. Class AR 0.5 wear depth 0.05 mm, very heavy duty, very intensive use, for example in a warehouse. Class AR1, wear depth 0.1 mm, heavy duty, intensive use, for example in a warehouse. Class AR2, wear depth 0.2 mm, medium duty, industrial commercial uses. Class AR4, wear depth 0.1 mm, light duty, industrial commercial uses. After we know the value of average wear depth, we can use this value to classify the type of floor, according to the standard BS1381. The value of average wear depth is 0.209 mm, so this means we can classify the type of floor as AR2. From the two testing methods we can see the main differences between the two are: 1. BS can immediately classify type of floor, but ASTM only measures the strength. 2. BS can be carried out in a field test and in a lab, but ASTM can only be tested in a lab.
Wow, I got it. Thank you so much for this knowledge.
And what about your homework, Monica?
I forgot it.
Run.
Nobita!